So in this lesson, we will multiply and divide rational numbers. So we're going to start with this first problem. And there's two ways I can approach it. One would be to use distributive property, which we have been practicing in class. And the other is to use order of operations. So I think I'm going to start with order of operations in this situation, which tells me I'm going to do what's inside the parentheses first, and then I would multiply it by a negative 12. But in order for me to add what's inside the parentheses, you'll notice that you will have to find a common denominator. I can't, and this is a common misconception, is that you can just sort of add these two and you would see something like 3/7, right? Because you added the top and the bottom numerator and denominator of the fractions, and you cannot do that when you are adding. So what I'm going to do is use this little side space to actually work out to figure out what a common denominator would be for both of these fractions. One way to do that is to find the least common multiple. So that means I could multiply 3 times 4 together, and one multiple that they share is 12. 12 is also the smallest one. They also share other multiples. I can say 36 is a multiple that they share. I'm drawing a blank now, but they do share other multiples, but 12 is the smallest. So that's actually a good one. It doesn't matter. It's just a good one. So now I can multiply 4 times 3 to give me 12. So I'm going to do the same on the top. And 3 times 4 gives me 12. So again, I will multiply the same on the top. And so we just found two equivalent ratios to our original fractions, 8/12 and 3/12. So now I can actually add them. So I'm just going to put those in here. And I could just get rid of that. And now I could just go ahead and add across. 8 plus 3 is 11. Now again, when you're adding fractions, unlike when we made our, sort of went through the example up here, we do not add our denominator. So the 12 is going to stay the same. And now I want to multiply that by negative 12. But, well, I could actually do it. I could multiply negative 12 times 11, right? And then divide it by 12. But I want to divide out a common factor before I even get started, because that's going to save me a little bit of time. So if I look at this problem, and I'll just write it like this, negative 12 over 1 times, because that's what the parentheses mean. This means negative 12 times 11 over 1 times 12, right? I can divide out a common factor from both the top and the bottom. So I notice that this one has a 12, and I probably should change the color here. And this one has a negative 12. Both of them share a common factor of 12. So if I divide 12 from 12, I would have 1, and this stays at 11. And if I divide 12 from negative 12, I would have a negative 1. Or I could sort of cross this out, be left with negative 1 and 1. And you would notice now I have a negative 1 times 11, which would give me a negative 11. That saved us, I would think around, for me, it might have saved me around 3 minutes of extra multiplying negative 12 times 11 and then dividing out the 12 again. Okay? So that was one way to solve it using order of operations. Now we're going to solve it using distributive property. So in order to do that, and I sort of like this way when I have these two fractions, because I just would save that extra step of finding the common denominator. And that is, I'm just going to multiply the negative 12 times 2/3, and I'm going to multiply the negative 12 times 1/4. Then bring down the addition. All right. So, and again, if it helps you just to see these as multiplying two fractions, you can add that 1 on the bottom. So then I'm just going to go straight across, right? When we're multiplying, we can just go straight across. unlike adding, as we just found out. So negative 12 times 2 is 24. Oops, scratch that, negative 24. And then I have a 3. Plus negative 12 times 1 is negative 12 over 4, or negative 12 fourths. So you're probably looking at these two numbers and saying, I can definitely divide out the denominator from the numerator, right? I can make this into an integer. So negative 24 divided by 3 would give us negative 8. Negative 12 divided by 4 would give us negative 3. And again, if I add these together, I would get the same answer as we got before, negative 11. Two different strategies, both work. So now we're going to look at this problem. And I kind of like this problem. One, because it allows us to do some commutative property, which we have been practicing with addition, but in this situation, we're going to use it with multiplication, right? And commutative property tells us that we can move the order in which we sort of set up a multiplication problem. Okay, I'm going to stress that multiplication or addition problem doesn't matter because it's, well, if I multiply 1 times 3, it's 3. And 3 times 1 is 3. So it doesn't matter. It doesn't change the product. So we're going to do that with this one. I'm going to make this pen a little bigger. All right, let's see. So now I want to change the order because I want to have my two integers next to each other and I want my two fractions next to each other. So I have negative 6 times negative 12. Notice it doesn't matter that I've changed it from parentheses to the raised dot, right? It's the same operation. And then I'm going to bring the 1/4 here and the 2/3, right? I applied the commutative property. So now we can figure out that a negative times a negative is going to give us a positive, and 6 times 2 is 12. So if I just want to bring that down, I have 12. And I can do the same here, multiplying straight across. I could do something different, but that's okay. I have 1 times 2 is 2, and 4 times 3 is 12, right? So we are now in a situation similar to the one that we were in before, where we have 12 over 1 times 2 12s, and I can divide out a common factor of both of these, right? They both share 12 as a factor. So that would give me 1. This also shares 12 as a factor. That would also give me 1, right? And then 1 times 2 is 2, and 1 times 1 is 1, or the answer would be 2. So imagine that I didn't see that right away, right? I didn't see that I could divide out the 12. Well, then I could just go straight across, and that's what we're going to do now. So 12 times 2 over 1 times 12. So on the bottom would give me 12. And on the top, I would have 24. And now this fraction bar, again, means division. So 24 divided by 12 equals 2. Two ways, both of them work. Okay? So you see this problem and you say there's a lot of, there's a lot of integers, a lot of operations going on. Well, just one operation, multiplication, really. Some division. And you might sort of get a little confused or concerned. Don't be. Take it step by step, and it turns out pretty much the same either way. Okay. I'm going to skip that one, but I actually kind of like this problem. So we're going to look at this one. We're going to apply the commutative property again, just to put these two fractions greater than 1 on one side, and then this negative 3 times negative 5/10 on the other side. Okay, so I'm going to start there. I'm going to do the 8/5 times negative 5/2. And again, I'm just using the raised dot. You do not have to. You can use the parentheses, right? All this whole expression is multiplication, so I can change it, right? And then I'm going to bring the other two down, negative 3 times negative 5/10. And because that decimal is going to probably bother me, because it looks like my multiplication sign. I'm going to change this -5/10 into -1/2 because half of a dollar is 50 cents. All right, so now I'm just going to multiply straight across just for this part right here. I don't have to. You might see already the shortcut you could take. -8 times -5 would give me a positive 40. And 5 times 2 would give us a positive 10. And for right now, that's fine. I could simplify it right now, or I could just leave it. Times -3 times -1/2. Okay? So now I'm looking at this and I'm like, yeah, I think I want to simplify it. I want to divide 40 divided by 10, which would give me 4, right? And I'm just going to put that right here. But then I want 4 times -3, right? So 4 times -3 would give me -12. And then I want to multiply that times -1/2. And again, I could go straight across. These are both negatives, right? So it's going to give me a positive, as I write a negative. It's going to give me a positive 12 over 2, which would 12 divided by 2 is 6. At this point, you can also say, well, half of 12 is 6. So that's how you can get your answer. Or you could divide out this sort of diagonally. I could do it top to bottom, but diagonally works in this case. 12 divided by 2 is 12 divided by negative 12 divided by 2 is -6. And 2 divided by 2 is 1. And then a -6 times a -1 would give us a positive 6. So both of these ways work. All right, hopefully this helps. Talk to you later.